Hey there, and welcome to Saltwater Stories.
Glad to be here.
Okay, picture this. You're walking through a forest, but instead of green leaves everywhere, all you see are these bare gray branches
Yeah.
reaching up towards the sky like, I don't know, skeleton fingers. Pretty
Mm.
spooky, right?
Definitely has an eerie feel to it.
Well, these silent woods are actually showing up along coastlines all over the world.
That's right.
And what's really interesting, maybe surprising, is that these ghostly landscapes, they're telling us a really important story.
A story about the changes happening to our planet. Yeah.
So today we're going to explore this fascinating and, yeah, kind of spooky world of what people are calling ghost forests.
Exactly. And these aren't just, any old dead trees. They're actually signals, indicators of some pretty big shifts happening in our coastal ecosystems.
Okay, signals. So what are we looking at? What exactly is a ghost forest?
Well, think about a spot where a healthy forest used to be, maybe right near the coast, or by a river that flows into the sea.
Okay, lots of trees, green stuff.
Right. But now, instead of all that life, you see the remains,
Hmm.
the trunks, the bare branches.
Uh-huh.
And often they're standing right in or very near water that's kind of salty.
Huh.
We call it brackish water.
Brackish.
Yeah.
So like a mix of fresh and salt water.
Exactly. Some scientists even use descriptions like giant graying pillars
Wow.
or even wooden tombstones. It paints a picture, doesn't it?
It really does. Wooden tombstones. So what's causing this? Why are healthy forests turning into, well, this?
The big drivers, the main things pushing this, are rising sea levels. Scientists often shorten that to SLR. You might see that written down.
SLR, got it.
And the saltwater intrusion that happens because of it.
Saltwater intrusion. So the ocean water is moving inland.
Precisely. As the sea level gets higher, that salty ocean water pushes further into areas where fresh water used to be dominant.
Okay.
And most of the trees you find in these coastal forests, they can't handle that much salt.
So it's like poison to them.
It basically acts like a slow poisoning. Yeah. It disrupts how they function, how they take up water, everything.
The name ghost forest really makes you think of something lost, something gone. Is that the main idea?
That sense of loss is definitely there. I mean, it's a very striking visual. You see what used to be a thriving forest.
Yeah.
But it's also important for us, for kids listening, to understand it's often a transition. These areas are changing.
Changing into what?
They might become salt marshes, or maybe areas with more salt-tolerant shrubs, or even just open water eventually.
Ah, okay. So it's not just death, it's change.
Exactly. It's a shift from one type of coastal habitat to another. Now, this kind of thing, forests moving inland as sea levels changed, that's happened naturally over, thousands and thousands of years. Geologic time.
Right.
Slowly.
Very slowly. But what the research is showing and what the articles you send highlight is that it's happening much, much faster now.
Faster. And the evidence strongly points towards human-caused climate change, really accelerating the whole process, especially the sea level rise part.
Okay. Climate change speeding things up. And does this affect more than just the trees? Like, what are the ripple effects?
Oh, absolutely. Huge ripple effects. Ecologically, it changes everything. Where animals can live, what plants grow there, the biodiversity, the variety of life can decrease.
Mm-hmm.
It even affects things like how carbon is stored or released. Forests are great carbon storage. Marshes less so, sometimes.
And what about people? Does it impact us directly?
Definitely. Think about fishing industries that rely on healthy coastal waters, or farming near the coast. Salt water getting into fields is a big problem.
Yeah, I could see that.
Even property values can be affected if the coastline is visibly changing like this.
And you said this is happening globally, not just here.
That's right. A lot of the really detailed studies have been done on the Atlantic and Gulf coasts of North America. They're kind of hotspots. But yeah, we're seeing similar patterns, similar ghost forests appearing on coastlines around the world.
Okay, so let's dig into the how. How does a vibrant forest actually become one of these ghost forests? Walk us through that process.
Okay, so step one, the underlying pressure, is that rising sea level we talked about. The ocean is getting higher.
Right.
As it rises, it starts pushing that salt water further inland, both on the surface, like in rivers and creeks,
Right.
and also underground.
Underground, too.
Yeah, that's the saltwater intrusion part. That salt gets into the soil, into the groundwater that the tree roots rely on.
And that's the direct hit on the trees, the salt itself.
That's the direct stressor, yes. That increase in salt or salinity is what causes the slow poisoning.
Is that the only water problem, just the salt?
Not quite. Rising sea levels also push up the level of the fresh water that's naturally underground the water table.
Okay.
So even without direct saltwater flooding, the ground can become waterlogged, saturated.
Like soggy soil all the time.
Exactly. And tree roots need oxygen to survive, which they get from air pockets in the soil. If the soil is constantly filled with water, the roots basically suffocate.
Oh, wow. So they're getting hit with too much salt, A&D, maybe not enough air.
It's often a double whammy, yes.
Oh.
The salt stress plus the stress from waterlogging.
Oh.
A really tough combination for most trees that aren't adapted for it.
You also mentioned something about the land itself sinking. How does that play into it?
Right. Land subsidence. That's a really key factor in some places. It means the land surface itself is actually going down.
Sinking. Why would the land sink?
It can happen for natural reasons, like after the last ice age, huge glaciers melted, and the land in some areas is still slowly adjusting. That's happening around the Chesapeake Bay.
Ah.
Or in places like the Mississippi Delta, the ground is made of soft mud and sand sediment that naturally compacts and sinks over time.
So the land goes down, the sea comes up.
Exactly. It makes the relative sea level rise how much the water rises compared to the land right there even faster. It magnifies the effect.
Are there human causes for land sinking too?
Unfortunately, yes. Pumping out large amounts of groundwater or oil and gas from underground can cause the land above to compact and sink. So our own actions can sometimes make the problem worse.
Man, okay. So it's a gradual process mostly? Or can it happen fast?
It's often a mix. You have the slow creeping pressure from sea level rise and gradual saltwater intrusion weakening the forest over years.
Right.
But then, bam, a big event can trigger rapid, widespread die-off.
Like what kind of event?
Big storms, hurricanes. Think about the storm surge, that huge wall of seawater they push ashore.
Yeah.
That can force massive amounts of salt water really far inland, really quickly, and just overwhelm a forest, even one that was sort of coping before.
So a storm could be like the final straw.
Exactly. Droughts can do it too, in a different way.
Droughts. How does less water cause a saltwater problem?
Well, when you have a drought, there's less fresh water flowing down rivers and streams towards the coast. That freshwater flow normally helps keep the salt water pushed back out towards the ocean. When the freshwater flow drops, the salt water can push further upstream, further inland.
Ah, I see. And it can get into the groundwater more easily then too.
Precisely. Less freshwater pressure means the saltwater interface, where the fresh and salt groundwater meet, moves inland.
And you mentioned drainage ditches earlier. How do they fit in?
Right, human modifications. We've built lots of canals and ditches in coastal areas, often to drain swamps for farming or building.
Yeah, makes sense.
But now, with rising sea levels, those same ditches can act like superhighways, carrying saltwater inland much faster and further than it would go naturally.
So something built to control water is now letting the wrong kind of water in.
In some cases, yes. It's an unintended consequence. And finally, just the shape of the land matters. Flat, low-lying coastal plains are just naturally more vulnerable. A small rise in sea level can cover a large horizontal area.
Okay, that makes sense. Let's circle back to sea level rise itself. You said it's the main driver. What's actually making the oceans rise?
Two main things, both linked to our warming climate. First, as the oceans get warmer, the water itself expands, just like liquid in a thermometer expands when it gets hot.
Thermal expansion, right?
Exactly, thermal expansion. That accounts for a good chunk of it. The second big part is melting ice.
Glaciers and ice sheets.
Yep, glaciers on mountains all over the world and the massive ice sheets covering Greenland and Antarctica. As they melt, that water runs into the ocean, adding to the total volume.
And you said this is happening faster now.
Yes, the scientific data is really clear on that. If you look at the 20th century, the average rate was about 1.4 millimeters per year. Sounds tiny, right?
Yeah, really small.
But think about the entire ocean surface. It adds up. And then between roughly 2006 and 2015, that rate jumped to about 3.6 millimeters per year.
Wow, more than double.
Yeah. And just last year, 2023, the global average sea level hit a record high since we started using satellites to track it accurately back in 1993. It was over 100 millimeters. That's about 4 inches higher than in 1993.
4 inches in 30 years? Okay, I can picture that better. And it's speeding up.
It is. And that acceleration is the really worrying part for ecosystems and for us.
But you also mentioned it's not the same everywhere. Why does it vary from place to place?
Right. That's the concept of relative sea level rise, or RSLR. The global average is one thing, but what you experience right at the coastline depends on local factors too.
Like the land sinking we talked about.
That's a huge one. If the land is sinking, the sea level rises even faster relative to the land. But other things matter too, like Changes in ocean currents can pile up water in some areas more than others. Even gravity plays a tiny role with those giant ice sheets melting.
So some coasts are getting hit much harder.
Definitely. The U.S. Mid-Atlantic coast, think North Carolina up through Massachusetts, that whole stretch is known as an RSLR hotspot.
A hotspot? Why there?
It's a combination of factors, including that land subsidence from the glacial adjustment, plus changes in ocean currents like the Gulf Stream. Rates there are roughly 3 times the global average.
3 times. No wonder there are so many ghost forests there.
Exactly. In places like coastal North Carolina, we're seeing 3 to 4 millimeters per year. Around the Chesapeake Bay, it's closer to 6 millimeters per year.
Wow.
Ecosystems just can't keep up or adapt when the change is that rapid. The trees literally drown or get poisoned faster than they can migrate inland, assuming there's even space to migrate.
And looking ahead, what are the predictions? What does the future hold?
Well, the projections are serious. Even with significant cuts to greenhouse gas emissions, like globally, we're still locked in for at least another foot, maybe more, of global sea level rise by 2100 compared to the year 2000 levels.
Another foot, even if we cut emissions.
Yeah, there's a lag in the system. The oceans have absorbed a lot of heat already, and the ice will continue to melt for a long time. And if emissions stay high, well, the projections get much scarier. Some studies suggest rises exceeding 6 feet are possible by 2100.
6 feet? That's
Yeah.
huge. That would flood enormous areas.
It would. It would redraw coastlines. There are estimates that just 1 meter, about 3 feet of sea level rise in the U.S., could turn thousands upon thousands of square kilometers of what's currently dry land into tidal zones, flooded regularly.
So more ghost forests are basically guaranteed at this point.
Because of the warming that's already happened and the lag effect, yes, further expansion of ghost forests is pretty much locked in for the coming decades, unfortunately.
Okay, let's zoom back in on the salt itself. Saltwater intrusion. You said it's the salt moving into freshwater areas. How exactly does that work underground?
Right. So naturally, in coastal areas, there's a zone underground where the lighter freshwater coming from rain and rivers soaking into the ground sort of floats on top of the denser salt water that seeps in from the ocean.
Okay, like oil and vinegar.
A bit like that, yeah. There's a transition zone.
Yeah.
But as the sea level rises, it pushes that whole saltwater layer higher and further inland underground.
And that's bad for the trees because
Because most of these coastal forest trees, pines, oaks, cypress, maples, they're adapted to fresh water. They're called glycophytes, which basically just means sweet plant preferring low salt. They have very limited ability to tolerate salt around their roots.
what does the salt actually do to them? How does it kill them?
It's that two-pronged attack we mentioned. First, osmotic stress. If the water outside the roots is much saltier than the water inside the root cells,
Uh-huh.
it actually makes it harder for the tree to pull water in. The salt gradient is wrong. It's like the tree is thirsty, even if the ground is wet, because it can't physically absorb the salty water efficiently.
So it gets dehydrated even while sitting in water.
Essentially, yes,
Yeah.
at a cellular level. The second problem is ion toxicity. When the tree does take up some of that salty water, it accumulates too much sodium and chloride ions inside its tissues.
And those are bad.
In high concentrations, yes. They mess up the tree's internal chemistry, damage cell membranes, interfere with photosynthesis. It's that slow poisoning effect again. It just disrupts their fundamental life processes.
And you mentioned younger trees have an even harder time.
Absolutely. Seedlings and saplings, the baby trees, are way more sensitive to salt than big established trees. Their root systems are smaller, they have fewer reserves.
So the forest can't regenerate. New trees can't grow up to replace the old ones.
That's often what we see first. Salt levels might get just high enough to stop new trees from sprouting or surviving their first few years, even while the bigger trees are still hanging on.
Creating that non-regenerating zone you talked about.
Exactly. It's like the forest loses its ability to heal itself or replace itself. It becomes an ecological ratchet. It can only really go one way, towards decline, unless the salty conditions somehow reverse, which is unlikely with ongoing sea level rise.
Even tougher trees, like maybe pine trees, struggle with this.
Yeah, even species like loblolly pine, which is known to have moderate salt tolerance compared to, say, an oak, it still has its limits. Prolonged exposure to salty, waterlogged soils will eventually stress and kill even relatively tolerant species if the levels get high enough.
Okay, so the salt gets there through surface flooding, underground flow, and those ditches. Does the salt stick around for a while?
It definitely can, especially in the groundwater. Surface flooding might wash away relatively quickly, but the salt that seeps into the soil and groundwater can persist for a long time, continuing to stress the trees long after a storm has passed.
And scientists are trying to figure out the exact tipping points, like how much salt is too much.
Yeah, there's a lot of research looking at critical salinity thresholds for different species. And again, it's often the combination high salt plus waterlogged soil that's the most damaging cocktail for these trees.
When the trees die off, does anything else move in? Any plants that actually like the salt?
Yes, nature doesn't usually leave a vacuum for long. As the salt-sensitive trees die, you often see salt-tolerant plants start to take over.
Like what?
Certain shrubs become more common, like bacchus, which people sometimes call saltbush or wax myrtle, morella. You'll see more salt-tolerant grasses move in. Sometimes invasive species, like the common reed, phragmites, can really take hold in these disturbed transitional areas. Even poison ivy seems to do okay sometimes.
Poison ivy, great.
Huh. Yeah, maybe not our favorite, but it's adaptable. So the saltwater intrusion acts like a filter, selecting for plants that can handle the new conditions. This leads towards those new ecosystems, like salt marshes.
But maybe not as diverse as the forest was?
Often, yes. The resulting marsh or shrubland might have fewer species overall than the complex forest it replaced. And as I mentioned, they can sometimes be more vulnerable to being dominated by just one or two aggressive species, sometimes invasive ones.
Okay, so we've got sea level rise, saltwater intrusion. But you said there are other factors too, right? It's not always just that.
That's right. While SLR and SWI are usually the main story, other things can definitely contribute or make the situation worse. We already talked a lot about land subsidence magnifying the effect.
Right, the sinking land.
And those extreme weather events, hurricanes especially,
Right.
they don't just cause flooding. The physical force of the wind and waves can also damage trees, making them weaker and more susceptible to the salt stress that follows.
Like that example in North Carolina you mentioned, with the drought first, then Hurricane Irene.
Exactly. The drought likely stressed the trees, maybe lowered the water table, allowing some initial saltwater intrusion. And then Irene's storm surge was just too much for the weakened system to handle. Yeah. A real combination punch.
And droughts themselves, even without a hurricane right after, can worsen things.
Yes, by reducing that freshwater flow that normally keeps saltwater pushed back, allowing the salt front to creep further inland, especially, again, if there are drainage ditches providing easy pathways.
And other human stuff, besides the ditches and causing subsidence.
Yeah, think about general land use changes. Removing natural buffers like coastal wetlands or dune systems can expose inland forests more directly to storm surges and saltwater.
Okay.
And then there's coastal squeeze.
Coastal squeeze, what's that?
Yeah. Imagine a natural marsh or forest trying to migrate inland as sea level rises. But then it hits a road or seawall or a housing development.
It's trapped.
Exactly. It gets squeezed between the rising water and the immovable human barrier. It has nowhere to go, so the ecosystem just shrinks and eventually gets drowned or salted out.
So it sounds like it's almost always a mix of things.
Very often, yes. It's a gradual pressure building up, maybe combined with some human modifications to the landscape, and then maybe a trigger event like a storm or drought pushes it over the edge. You could even have other weird interactions, like maybe a big wildfire stresses the trees, and then the saltwater impact is worse. Or maybe climate change allows forest pests to thrive, weakening trees before the salt gets them.
And you mentioned earthquakes too.
Right, in specific places like the Pacific Northwest, a massive earthquake can cause the coastline to suddenly drop several feet. That's tectonic subsidence. That can instantly flood coastal forests, creating ghost forests overnight almost. The Nescoting Ghost Forest in Oregon is a famous example, formed by an earthquake centuries ago.
Wow. Okay, so where are we actually seeing these? You said the U.S. East Coast is a hot spot.
Yeah, definitely. The Atlantic coast from North Carolina up to Massachusetts, that's prime territory because of the high relative sea level rise in the low-lying land. The Chesapeake Bay, the Outer Banks, and Albemarle-Pamlico region in NC Win. Lots of well-studied examples there.
And the Gulf Coast too.
Yep, the Gulf Coast is seeing it widely too. Also has SLR, plus significant subsidence, especially around the Mississippi Delta, and of course it gets hit by strong hurricanes. So places in Louisiana, Florida, Alabama, Mississippi, Texas are all experiencing ghost forest formation.
Further north, Canada.
Yes, examples in Atlantic Canada too. Around the St. Lawrence estuary, parts of New Brunswick. It's happening where salt-intolerant forests meet vulnerable coastlines.
And the Pacific Northwest, mostly the earthquake-related ones.
Historically, many of the most dramatic ones there, like Nescoin, are linked to those big earthquakes, causing sudden subsidence. But ongoing gradual sea level rise is certainly a factor now along that coast too, contributing to stress on coastal ecosystems.
What about outside North America? You said it's less documented.
It seems to be, based on the research focus we looked at. That doesn't mean it's not happening, but maybe it hasn't been studied as intensely everywhere, or maybe coastal defenses in some areas mask the effect.
Or maybe it looks different elsewhere.
Possibly. Different tree species might react differently, or the transition might be to a different type of ecosystem that doesn't leave such stark skeletons.
But there are some examples.
Oh, yeah. We mentioned the mangrove ghost forests in Australia, particularly after extreme weather like severe droughts or cyclones. Places like the Gulf of Carpentaria have seen huge mangrove die-offs.
But less documented in, say, tropical Asia or Central America.
Seems that way from the general literature, even though we know mangroves are under stress in many of those regions too.
Yeah.
It might just be a gap in easily accessible research or reporting focused specifically on the ghost forest phenomenon as it's defined in North America.
And just to be clear, this isn't the same as like forests killed by bugs inland.
Right, good distinction. Those inland ghost forests, like ones killed by mountain pine beetles out west, have a totally different cause. We're focused here on the coastal ones, linked directly to saltwater intrusion, driven primarily by sea level rise. Different process, different story.
So bottom line, ghost forests pop up where salt-sensitive trees meet coasts that are vulnerable to rising seas.
That's the essence of it, yeah.
So listening to all this, it's clear these ghost forests are, wow, way more than just some spooky scenery you might see on a coastal trip.
Absolutely. They're a really visible, almost undeniable sign of these huge changes happening along our coastlines.
Yeah, they really bring home the impact of rising sea levels, that saltwater intrusion, on ecosystems that are, well, pretty delicate.
They really do. It connects the dots between climate change, sea level, and real-world consequences that you can actually see standing right in front of you.
And the story these dying trees tell, it's connected to everything else, isn't it? To climate change, to the challenges people living on the coasts are facing, the challenges nature is facing.
It's all interwoven. Understanding why these forests are changing helps us grasp the bigger picture of what our coasts might look like in the future, and why addressing climate change and adapting to its effects is so incredibly important.
Well, we really hope this exploration has given everyone listening, especially our younger audience, a new way to look at these, haunting landscapes.
And maybe appreciate the really important messages they carry about our planet.
Thank you so much for joining us today on Saltwater Stories.